Mean value theorem is used for two other theorems that we use a lot. So the following theorem states if the derivative of a function is 0 for all x values in some open interval, then f is constant on that interval. And here's the proof of that. Again, using the mean value theorem, because that derivative is 0, that means that this expression is 0. And by the way, this little 2 should be inside this parenthesis. This expression 0. Well, we know that x2 minus x1 is not 0, so that's cool. But so this numerator is 0. But if that numerator is 0, that means that f of x2 equals f of x1, which means that for all x values in that interval, which means that the function is constant. Another similar theorem, functions with equal derivatives differ by just a constant. And that we're going to see a lot in the second half of the class. So again, we just set up the function that is the difference between the two functions that have equivalent derivatives. And that means that the derivative of this function is 0. Therefore, it's a constant function, so f of x and g of x have to just differ by that constant. So the last example is something called something called the racetrack principle. So this says show that the sine of x is less than x for x in this open interval. Well, I'm going to call sine of x f and x g of x, and I'm going to take the derivative of each of those. So the f prime is cosine x, g prime is just 1. I know that the cosine function is between -1 and 1. So that means that since cosine x is f prime of x and 1 is g prime of x, I know that f prime of x is less than g prime of x for all x in this interval 0 to 2 pi. So that means that f is growing at a slower rate than g, but they started off at the same value. Therefore, f has to be less than g on this interval. So sine of x is less than x on that interval. And if you look at it graphically, you can see where the sine of x and x are very close to each other for small values, but still equals x has a larger y value than sine x, even though they're very close as you get close to 0. And you might remember that we had seen that the limit of sine x over x is 1 because they're so close to each other for x near 0. So in summary, really these theorems are used to build up other theorems. So Rolle's theorem tells us that the function has a 0 derivative, so it turns around somewhere if it's going to have to go back to the same endpoint. The mean value theorem guarantees that there's a point where the tangent line to the graph is parallel to the secant line. And then mean value theorem is used to get other information about a graph. And we saw that with a couple of other examples. And then these are two things that we're going to use a lot in the class. Function with a 0 derivative must be constant, and functions with equal derivatives just differ by a constant.